Hi, it's Mrs. Matt with help on today's assignment, Unit 3, Lesson 2, Practice Problems in your book, page 15, numbers 1 through 5. For number 1, to write that expression without using exponents is just asking you to find the value of 7 to the negative 3 divided by 7 to the negative 5. And so because we're dividing, we are going to subtract the exponents. Remember, when you divide powers with the same base, the base stays the same, and you subtract the exponents. So negative 3, oops, I didn't put a minus sign in between. Negative 3 minus negative 5 is equal to positive 2. So this is equal to 7 to the second, which is 49. Number 2 is also reviewing the properties of exponents from earlier this week. Find the value of the variable that makes the equation true. So the first one is an example of a power to a power. When you raise a power to a power, the base stays the same and you multiply the exponents. So D has to be equal to 3, since 3 times 4 would give us 12. On part B here, I notice the bases are different, but the exponents are the same. So when you multiply powers with the same exponent, the exponent stays the same, and you multiply the bases together. So since 3 times 7 is 21, E is equal to 21. So 3 to the 5th times 7 to the 5th is equal to 21 to the 5th. And on part C, I notice there's a 5 to the 0 here, which is equal to 1. So you're really just multiplying 5 to the F by 1. So if you're going to do that, then F has to be 4 to get an answer of 5 to the 4th. All right, for number 3, a square has an area of 9 square centimeters. How long is its side? So remember that what we talked about today, if this is a square and it has an area of 9, then each side is equal to the square root of that area. And since the square root of 9 is equal to 3, then it's going to be 3 centimeters. Number 4 is a little more work with square roots. Table shows the side length of an end area of several different squares. Complete the table using exact values. And so I know that if we say the side length is x, then we can say the area is x squared. And so if I have a side length of 5, then the area is 5 squared, which is 25. And then for the second one, if the area is 49, then the length of the side is going to be the square root of 49, which is 7. If the side length is the square root of 63, then the area of the square is actually 63. So if you were to square the square root of 63, the answer is 63. In a similar way, I know that 98, because it's asking for exact values, 98 isn't a perfect square. So if it's the area of the square, then the length of one side is just the square root of 98. And same with the 102. So 102 also is not a perfect square. It's close. 100 is a perfect square. Its square root is 10, but this is just a little bit over 100. And so I'm going to write the length as the square root of 102. Again, the reason why I'm using that instead of my calculator is it clearly says to use exact values. And for the last one here, if the length of one side of the square is the square root of 125, then the area of that square is 125. And finally, for number 5, find two whole numbers that are the closest to the square root of 42. Explain your reasoning. So we did something similar to this in class today with cubed roots. We can kind of use that same idea. So if I think about taking all the numbers, integers, and squaring them, so 1 squared and 2 squared and 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and 7 squared is 49. Okay, so I know that the square root of 42 is going to be in between 6 and 7. How do I know that? Because 42 is between 36 and 49. So if 42 is in between those two numbers, then the square root of 42 is going to be between their square roots. So the square root of 36 is 6, and the square root of 49 is 7. So the square root of 42 is going to be between 6 and 7. And that is the end of your assignment. I hope that was helpful.